Well, once again, I'm under my RV, and today's little project is we're going to be dissecting an HWH hydraulic system or the tank pump motor assembly. Let me back up, tell you a little bit of a story. Last year, a fellow called me up for some of my YouTube videos. I was helping him troubleshoot his system. His problem was he had a Winnebago, and the hydraulic jacks would go down, but it wouldn't lift the RV. And I think the other symptom was his room would go out, but it wouldn't come back in. I'm pretty sure it was a storm or level floor where it goes down this ramp, so it would go out, but it didn't have enough power to bring itself in. So I explained to him, I sent him a link to the pressure gauge that he needed to do the test with. And sometime in this video before I get done, I'm going to do the same thing on this one. I'm going to put the gauge on it and show you exactly how to do a pressure test. But I wanted to get in here and explain some things to you before I get to the workbench and dissect his. But anyway, I told him to do that test. He did the test, and turns out he didn't have enough pressure for it to operate. And I showed him how to go about, telling him about this little adjustment bolt here. He can try to adjust the PSI. That didn't do no good either. So he called HWH to get a new pump. It's the only way you can get is a whole assembly. You got to get the tank, the hydraulic pump that's in here, and the electric motor. I think it was probably close to $1,000 last year. Who knows how much it is these days. And I got a video of showing how I installed that. He was in, because this was like last year, but I told him I'd be in Kissimmee in a few months, and he was patient. Actually, I think he called me back. That's how it went out. That's how it went. He couldn't find anybody to install it after he bought the new parts. And I said, well, if you can wait a couple months, I'll be down there. And I drove over to Tampa, and I took care of him. I'd never replaced one before. I didn't know what I was going to get into. Sometimes I'm too dumb to say no. But it really wasn't that bad, and that's why I made a video on it, so you can do it yourself. Actually, his was fairly easy because it was out on the front behind the bumper, so fairly easy to get to. One like this would be a little bit more trouble because it's kind of in a tight spot. We're in behind the front driver's wheel here, so it'd be a little bit more of a pain for this style, but it's doable. You just take documents, take your pictures, go slow. You can do it yourself, and just get all your wires back correctly. So anyways, I just want to point out a couple things. Of course, there's a reservoir tank, there's our pumps in here somewhere, there's a motor, this is our adjustment valve, and there's a warning, never ever remove this nut here. Looks like a bolt. The nut you can loosen, but the bolt inside here, I'm going to get a close-up, never remove that, and I'll show you why in a minute. And here, because we have our manifolds, we'll be talking about those, because the lower manifold, that controls the rooms, and the upper manifold is for the jacks. And we have the shuttle valve up here. Shuttle valve is, where are you at? Right there's the shuttle valve. And that could be problematic too sometimes. The shuttle valve kind of directs traffic for the hydraulic flow. And it can fail and do weird things where the jacks won't retract, or you can fail in a way where it can also mimic a bad pump. And maybe, I think, as a troubleshooting, that's right, it's coming back to me now, he did replace the shuttle valve, because sometimes a bad shuttle valve will mimic a bad pump, because if it kind of sticks in between, it doesn't give the pressures you need. So I think he did replace the shuttle valve, still had low pressure, so then he went and ordered the tank. I put it in, everything worked perfect. So that's something to keep in mind. But, and then I also want to point out to you, be wary, these caps up here where you add oil, whenever you take that off, you be mindful that you don't knock any dirt down into the tank. That's another thing I want to be curious about, if there's any kind of filter system inside this thing. And to think about, I believe we need to start changing oils in these things. Most all hydraulic systems, I don't know that I've ever seen a spec on HWH about when to change oil in these things. But no matter what kind of product you have, if it's a log splitter, anything with hydraulics, there's usually a recommended oil change routine. And like with these, you got a metal tank and they're just out here in the open, we're going to constantly get condensation. So water is always going to be getting in this oil and diluting it. And so I think that probably contributes to failure. I changed mine about 5 years ago, I believe. So I'm going to do that too. I'll probably make a separate video on changing the oil in these things and film them back up. That would probably be a good little video. All right, so you got an idea what we're doing here. So I'm going to go to the workbench and we'll start taking this thing, his old pump, apart. All right, so now we're on the workbench. This is the fella's old pump that's wore out, supposedly. So we're going to find out exactly why it's wore out and what it looks like inside. And so to give you an idea, remember all the manifolds are now gone, but this is our pressure port, and this is a return port. And I think the pressures on these things, I think the minimum you need is what it's looking for is 3,400 psi, maybe up to about 4,000. I got my spec sheet. I'll look at it in a second. And that's your return port. So when you hit the store button on your jacks, that's where all the oil gets dumped back into here. And so first thing we want to do is put a pressure gauge on it. So I'll get that screwed on there with one hand. Let me get a wrench on it, get it good and tight. And let's find a good 12 volt source, and we'll see what we got. Okay, so I got things wired up here. I got me a little battery here, and I've got a charger on it, throwing 2 amps in it to keep it topped off. So I have plenty of power. So I'm ready to do a test. But I printed out some information here just so we know we're doing it the correct way. Of course, a little bit differently. Normally, when it's in your RV, you'll be removing this loop and putting your gauge right here. Okay, because we don't have the manifold, so we're screwing right into the block here, right off the pump. But it tells you here, connect to 5,000 psi gauge, which we've done that, and it tells us the pump pressure should be 3,500 psi. And what else does it tell us? Voltage, if the voltage is less than 10 volts, pump pressure may be low. Minimum allowable pressure would be 3,300 psi. Maximum allowable pressure is 3,800 psi. So this will be interesting when I do it on mine to see kind of after 20 years what kind of pressures I'm maintaining. And the pumps have an adjustable relief valve. If proper pressure cannot be achieved, replace the pump. All right, so this is this valve here, which I'll explain to you why you never want to take this center bolt out. So because you can fine tune your pressure a little bit. So we'll see how that works on mine, because I'm suspecting this is not going to do so good. All right, and I did printed this out. It surprised me. I didn't realize, but we do have a strainer and a magnet. So once we get this apart, we'll see exactly what this looks like inside. All right. So, all right, we're ready to test this thing. See what happens. Woo, sparks, baby. Well, nope, that's not enough. What do we got? 500 psi. So that explains why he had to replace his. So we know we're not developing enough pressure, and this thing. I'll screw this in some more, just see if it makes any difference. I don't think it will, but we'll try it. Okay, so I've backed the jam nut back as far as I can. Turn this in just a little bit. So this would normally increase pressure. But let's see if anything changes. Whoops. I don't know, did it make a difference? Maybe look closer to 600 that time. All right, let me back it out and see if I can see a difference. All right, so I backed it out several turns. See, we got a big gap here. Let's see if the pressure changes any. No, still pretty sad. Nowhere near 3,400, or 3,500, whatever we need. All right, so now I guess we will start disassembling this thing. See what's inside. All right, I figure I'm going to dump this oil out. Before I do, I was going to talk about this vent cap. I did read about one thing that can cause failure of these pumps is if a cap is not vented. So if you want to check it, see you got 2 little holes here. You don't blow into that end. It's sealed off. That's a little nut driver thing to release the solenoids with. But just cover up one hole with your finger, then carefully blow in the other. And see. Yeah, it worked. Don't taste good, but this one's vented, so that wasn't its problem. But if this can't vent, if it can't draw air into the tank, it'll cause cavitation, and you'll get air, and it'll cause air to get inside the pump. And if in air is no lubrication, you've got to have hydraulic fluid flowing all the time. So that's one thing. Or running it low on oil could also cause the same thing and shorten the life of the pump. But also, I believe, is maybe where people are running this oil way too long. I got to do some more research on that. I can't believe there's not a recommended time period to change this oil. I think it should be a whole lot more often than what we're doing. Anyway, so we'll get this off. And one more thing I was going to point out. This is a very bad idea. On the older ones, they had little nuts on there you'd unscrew to relieve the pressure on the solenoids. Never do that, because if you do that, you're most likely going to get dirt and grit inside this little reservoir, that little plastic nut. And then you turn around and put that back in the tank. So all that dirt and grit, road grime, just goes into your tank. That's not a good idea. So get you a socket, whatever size that is. Looks to be about 1/4 inch. So do that instead. Don't rely on this tool. And be very careful. Oh, when you go to take these off, because usually you got all these hoses and wires in your way, and there's all kinds of dirt and grit. Well, let me show you what I like to do. I like to get me some, where's it at? Yeah, like, okay, this brake cleaner or mass airflow cleaner, something like that. Mass airflow cleaner might be safer because it's safe for plastics, but just take it and give a good blast all around that area. So that way when you take this off, you know you're not dropping any dirt or grit down in that hole. You want this perfectly clean, because there's all kinds of road grime can build up around that. You want to keep hydraulics clean as possible. All right, so got that ready. All right, let me dump this oil out. I'm going to see how much I get. I realize I'm a little bit, because it's not appearing on the dipstick. It's a little low. So we'll dump this out and get to taking it apart. Well, I don't know how much it is, but that's a whole lot of oil came out of there. A whole bunch. All right, let me get this oil out of my way. We'll start taking this thing apart. All right, step one, let's remove this motor. And in doing so, try not to break a bolt like I did. Just wouldn't come out. She was mighty tight. I've already cracked this one. This is a 7mm, by the way. Yeah. So that one came out okay, but that bottom one was rusted in there good, because it's 20 plus years old. I think this was maybe like a not 2003 model, maybe. Well, it's hanging on there, isn't it? Like a hair in a biscuit. Here she goes. All right. Motor's off. We know our motor is good. And whenever you do this, if you're doing this on your motorhome, you want to make sure you don't lose that little adapter, because it's in there. See if I can get it to fall out here. Get out of there. There she is. It's got some grease on it, so it held it in place. So yeah, you don't want to lose that part. Mess up your day. Alright, so what else we got? No more screws here. Looks like we got 5. I think those are 5/16. So let me get to taking those loose, and we'll see what we find. Alright, turned her up on its end a little bit better. I can see a little bit better what I'm doing. Here's those 4 little screws I removed. Toss that in my bucket. Remember also, don't lose this O-ring. If you're doing this in your driveway, I could drop off and get gone. Be mindful of that. And these kind of on there, kind of tight. Let's see here. We'll get a screwdriver under here. It's like Christmas, isn't it? What we're going to find? What's it going to be like in here? I like taking stuff apart. Okay, so which way? Ta-da! Looky there, folks. Isn't that pretty? Alright. Looks like we got some more stuff to take apart. There's inside the tank. Okay, there's a magnet. It said there's a magnet in here. I don't see a magnet. I'll fish around, see if I can see one, or feel for one. Well, the book lied to me, because there is no magnet in there. But look how nasty that oil is. Like I told you, I think we're getting a lot of condensation over the years. It's building up, and that's probably contributing to the failure of these pumps. Isn't that pretty? Just a work of art. Like I said, there's no magnet, but there is a pickup screen. The manual had that part right. But what's really amazing is this small, look how small this pump is. That thing can develop up to 4,000 PSI. That's amazing. Okay, let's look at our components here. So this is our suction, goes up into the pump. This is our return pipe. It comes down here, dumps it back in. Like when you hit the store button on your jacks, that oil goes down, gets pumped back into the tank. This is our bypass here. So like when we build up pressure, you know how when you bring in a room and you let it labor for about 3 seconds, let everything equalize, and you hear the labor, and you hear the sound changes, and that's where that bypass, that spring is opening up, and the hydraulic fluid's going past that ball and dumping that fluid back into the tank. Now, this is where I'm going to, remember I warned you never to take this out. Let me show you why. It's because if you take this out, let's see if I can get it to do it on me. Well, it's a long bolt, isn't it? All right, you take that out, and you try to fish out that ball bearing. There's a little ball in there. And actually, you'll notice the ball is gone. It's not there. You think, well, where did it go? You think, well, that's why it's not working. There's no ball. But what happens is, as soon as you take this out, the ball drops down into this pipe. Oops, see, you hear it? There it is. It fell out. I found this out because of one of my YouTube subscribers. He was troubleshooting his pump, and he found out the hard way. If you take this out, that ball is going to get gone. It's going to fall into the tank. I mean, it turned out his pump was wore out anyway. He had to replace the whole thing. But just to show you again, because normally that ball sits just like that. And you got this spring, and it's adjustable. So you adjust the pressure. Of course, our pump's too wore out to adjust. But as long as you lay it on its side, you're fine. But the moment, normally it's in this position, and then it falls right out. There you go. So that's why you don't want to do that. All right, so we got that figured out. So now let's find out what kind of tools we need to get this pump dissected. Okay, so easy enough. 5/16 Allen wrench is what you need. Take these two screws out and go around here. Alright, that releases the pump from the housing. And there's our little 4,000 psi pump. There's that little part that it grabs onto, the little flat spot. Okay, let me take the pickup off of it. Let me get this pump in a vise. Okay, here we go. It's got a little screen. Comes off. That's a drop that. Isn't that a strange looking thing? That just looks like a little plastic cap. They've drilled a pretty hole in the middle of it. I wonder what its purpose is. Why do you need that on there? Why not just have the strainer? Why wouldn't that be good enough? What's the purpose? I'm sure there's a reason. Maybe someone can tell me. Alright, so take this off. Now we got some weird screws we got to get a hold of. Simple enough. Now to get these two things off, these are called, it's called an E-socket. There you go, E-socket. And another reason I carry these in my, as we travel in the RV, I found this out the hard way. On our starters on the 8.1, if your starter solenoid ever fails, you want to change it out, you have to have this type of socket to remove that starter solenoid. It's a weird little socket. So, and the size we need is what? Just so you know, it's called an E7. So E7. Very strange little type of bolt. All right. Let me finish getting these long screws out of here. We'll see what's inside. And let me get two hands, make this quicker. Alright, so I took it out of the vise because you never know what's going to drop and fall. At least I'm here on the table with it. Those two screws are out. Yep, see there, something dropped out. Ball and spring. Now if I had it on that vise, it would have hit the floor and be gone. Alright, so there's our little pump gears. So we need to find out, why did this thing die? Okay, so that is, I did read about these things. They make these pumps two different ways. Some of these pumps, they make them reversing. So it'll go one way, then spin the other. So I can see why they would have, I guess in the reversing type, you would not have this ball and spring, because that prevents the oil from going out this pipe here. But in some applications, you would have it work that way. But in our application, you're going to have a spawn spring. So not all will have this. So that's pretty cool. Very small, delicate little part. So something about this is wore out. Let's see if we can figure out why. What's wore out about it. I tell you what, with all this oil in here, it's hard to tell. Let's clean it all up. We'll get it good and dry first. Well, we have found our problem. Now that I got the oil off there and got the parts all good and dry, you can see how much slop we got. Focus. And we'll go over on this side. Loose, loose. Now, I'll put it down the other hole. It's good and tight. Because that's the one where the idler sits. But up here, I guess that's the drive side from the motor. And you think, well, let's put a bushing in it, but that's not going to help anything because this part here is worn also. And that's the most important part between the gear and this housing, because that causes the oil just to bypass. It can't be forced around the gear teeth like it's supposed to. And same way with this. See, that side's good and tight, but you put it on the other side here. Look how much play we get. It don't seem like much, but in hydraulics, that's a whole bunch. So now, if we could just find this pump, that'd be great. But I've done some calling around. I don't think we can. But if anybody knows of this pump, if anybody can find a source or something like it similar, so that would be awesome. Okay, I want to give you a little update. First of all, I found this schematic is pretty cool to show how these little pumps work. So we're going to, on our suction side, how it grabs it, and it grabs the oil in between these gear teeth and just rolls it around the outer housing under high pressure and pushes it out. It's incredible. It gives us up to 4,000 psi. But that's why we need relief valves and springs and high pressure hoses, because hydraulic oil, it doesn't compress. It's going to go somewhere. So that's why it's important to have safety things in place so it has somewhere to go. But I've been doing some research trying to find one of these pumps, and I thought I found one. I did some Google reverse image searches. There is something on here. Let me see what it says. I've forgotten. Focus. IS. Which way is it? LSI, I think it is the logo. But haven't had any luck. But doing a reverse Google search of this pump, I came across this. It's identical. In fact, I ordered it thinking, aha, I got it. But when I got it in and took it apart, the housing was identical. But when I took it apart, the gear was about half as tall. So I know it wouldn't give me the volume and or the pressures that we need. So I sent that back. So I thought I was on to something, but this is for marine engine place. This is used, I believe, and it's a little hydraulic pump system that uses to control trim of a boat engine, raises it up and down. So I thought I was on to something, but I struck out. So if anybody out there can locate this little dude, that sure would be a big money saver for us. Because if you could get that for $200 maybe. I forget how much this one was. It was maybe $150 or something. If you could get one for $200 instead of spending $1,000 for the whole assembly, where if you've already got a good motor, a good tank, everything else is fine. We just need this pump because it's wore out. That would be great. But so far I've struck out. Maybe someone out there can have better luck than me. Please let me know if you find it. So that's all that's got dissected. So now I guess my next step, let's go down to the RRV and do a pressure test on it. So it's probably something it'd be interesting to know how to do. So let's go try that out. Oh, and before I head down there, I wanted to point this out to you a little as a teaser. One of my YouTube subscribers sent me this. This is a J72 pump for your W24s and some other different chassis. and not used on the W22s, but on the W24s, the early models. This is our auto parking brake system, and I'm going to dissect it the same way. I'm kind of curious if it's got a similar pump. Well, of course, its pressure is much lower. It's only like 1500 psi, but it will be interesting to take apart and put a gauge on it to see how it failed. I can't remember his failure. I'm assuming it was a low pressure situation where it wouldn't release the brake, but I don't know for sure, but that'll be in an up and coming video. So here's a little more information about this pump. Like I said, there's a logo, LSI. That's what I'm going to call it. That's what it looks like to me. LS1, LSI, there's the little logo. If we can track down this manufacturer, and remember these gears have to be exact to get our pressures. So the height of those gears is 325 thousandths, and diameter is 552 thousandths. So if we could locate this little pump, man, it would save us a lot of money. It would just be great. Or a replacement that would work just like it. You know, it has this type of drive on it. So someone out there that sees this video, maybe you can find something for us. Reach out to me. My cell phone's here under my contact information. Thanks. All right, let's readdress this pressure valve, the spring and ball here. And say, for instance, you've already screwed up and you've backed this all the way out and you possibly took it out. And when you did that, you noticed you got a spring, but you don't see no ball. You know, well, where'd the ball go? Well, it's dropped down into this little pipe. Of course, this is all assembled. You ain't going to see none of this stuff. And you most likely it's going to be inside the RV. Thing's pretty long. So there's your spring. You're going to say, well, I got no ball. No wonder I got no pressure. Well, what you didn't know is as soon as you took that out, that ball probably fell down in that little hole in there. Let me see. Yep, there's no ball. I swear there was a ball there just a minute ago. All right. It's what I just don't understand this design, but that's the way it is. So as soon as you back it out, you lose that ball. It drops down into that hole. Now, it doesn't necessarily roll down this pipe and fall into the tank, where maybe you can fish it out. You got to blow some air into it. So let's try that. Let me get something here. All right, working with one hand here. I just put a rubber hose in here, and I'm going to try to blow into it and see if that ball won't drop down in what would be the tank. There you go. All right, so that's what would happen. You would blow the ball down into the tank. Now you got the fun part of fishing the ball out, because now this ball is going to be inside this tank, and the only way to access it is through this little hole, unless you completely dissect everything, and that's not going to be any fun. The other option is, well, let me finish my thought. I thought, how would you go about fishing it out? One thing I thought of, because it is a steel ball, you could possibly take a magnet like this, stick it on the end of a little rubber hose, and then just stick it in there. And if you got really lucky, just poke around, run around all day, hopefully get a hold of that ball, then pull it out. Ta-da! And then you happy days. But if that doesn't happen, let me get a micrometer on this thing. We'll give you the dimensions of this ball, so maybe you could track one down if need be. All right, there's our dimensions. We're 187 thousandths. And or let's get our millimeters. And or 475 millimeters. So that's the little, that's the size of the ball bearing that you're looking for if you happen to lose it. Now you got the trick. You still got to get it back in there. So how are you going to do that? So my thought would be to just magnetize it and then stick it with my spring go. Then stick it on that spring. That would be my trick. Magnetize it, because everything else is aluminum. See if you got it. I wonder if that would work. Let's try that. Okay, I think this idea might work. I've got here, this is a very strong magnet out of a computer hard drive I dissected. And so I've magnetized the spring. Very strong. And then get the ball picked up. It's trying to. Well, I had it a minute ago. There it goes. All right, so that would probably work. let's test this theory. Let me, hang on, I need two hands again. Okay, so you get the idea. So right there it is holding. I really need one of those magnetizer, demagnetizers. But if you get that magnetized, get up in here, put it in place. Hopefully that would be the trick. I think that's what I would try to do. Then that way you wouldn't lose it again. But probably want to get something to make it a little bit stronger, because if I tap it, it falls off. So if we just get a stronger magnetism on that spring or the ball, might be an option. I'm just thinking. Of course, you've always got the possibility of, putting a dab of grease on the end of it. I don't guess that would hurt anything. Seeing that's probably another option, but I first thought, I don't know how grease is going to act inside of this hydraulic pump, but I assume it would quickly get dissolved and be okay. But that's another option. Because the best option is just don't do it to begin with. But we all pay stupid tax, so it could happen to anybody. Okay, this video is going to run longer than I thought, so I'm going to change it up a little bit. Instead of try to get all this information in one video, I'm going to break it up. So we're going to finish up this one talking about the tank and the pump and why it failed. I'm going to address that. But as far as the pressure test, I'm going to do that separate because that's got more involved and I've learned a few more things. I want to make that a dedicated video. And then on my third video, I want to do an oil change. And let me tell you why I want to do that. Because look here in this tank. So I can get a better light on it. See that oil, all that milkiness? That is water contamination. Now this particular model, the one, it sits out on front, right behind the front bumper. But regardless, this is like 20 years old. Any of these tanks, they sweat. And HWH will not give us a spec on when they want us to change oil. I reached out to them. They said just change it when it gets contaminated. Of course, obviously, this is contaminated. But it's kind of difficult to tell when it's normally assembled and all you guys have that little bitty hole to look into. So I'm going to try to figure out a good oil change routine for us that we need to look at and address. One thing, we'll talk about condensation. Anytime you got a metal tank like this, you get temperature changes, you're going to get sweat, and the water will get in there. An example, well, point out this way, like our own-end generators, the own-end maintenance manual will tell you, regardless if you use the generator at all, they still want you to change that oil every year, just from sitting there, because any motor, anything like that, any container is going to sweat. You're going to get condensation in it. Another thing I found out is Spartan chassis manufacturers build the great big diesel pushers. They got those huge diesel differentials. Well, in the Spartan service manual, they want you to change your oil in the differential every year. One reason, because it's different like an engine. An engine gets hot enough, if there's any moisture in there, it'll flash off and get out of there. But a differential, tanks like this, they never get hot enough to boil off, if that's the term, or flash off the moisture. So it just builds up. So you take a differential, that great big round can, and you get temperature changes, it will sweat and water will slowly drip in there and dilute the oil. And a lot of times differentials with RVs, they sit there for a long time, and those gears half of the gears are exposed to the air, because only half, like the big large bull gear, only half of it is submerged under oil. And all that time, water dripping on it could cause pitting and trouble. So, especially with RVs where they sit so much. So that's the thing we need to think about. And another thing I want to show you an example of this. Look at the difference. So this is the oil that came out of this pump, and this is new oil. So what would you rather have going in your hydraulic system? Now also to think about is how expensive these are. I just found out the new price on these things are now pushing $1,300. So, and remember, we can't get just the pump. I'm hoping, man, it'd be great if somehow, some way we can locate the manufacturer of this pump. Even if you get it for $200 or $300, because there's nothing wrong with the tank. Usually the motors are okay. You can always put brushes in those. I got a video of you can rebuild those little motors, put brushes on them. But this is the problem child here. When they wear out, our only option is to spend $1,300 on the whole assembly. So that bugs me, but that's the way it is. So we need to be thinking about that, how to check our oil, examine it, see what it looks, give it a comparison. Now, RRV, I went back and looked at my notes. I did change my hydraulic oil, but man, it's been 10 years ago. It's when my shuttle valve went bad, and I pumped all the oil out of the tank. And that's another thing I've been trying to experiment. It's kind of a pain getting the oil out of these tanks. So I'm going to try to come up with an efficient way for us to change oil. So that's going to be in my next video. But anyways, I think that's been pretty interesting, tearing this thing down, checking it all out, how it all works. It's been interesting to me, and talk about that ball spring and what not to do. So I'm gonna wrap this part of the video up, and then I'll get to working on 2 more videos, and we'll get that posted up as soon as we can. Alrighty, thanks for watching. Have a blessed day. See you, bye.